In question 2, we have a pickup truck with a weight of 14,000 newtons and a length of 4.5 metres. We're told when carrying no load the centre of mass is 2 metres from the rear end as shown in the diagram, and the part of the vehicle shown shaded in grey is supported by 4 identical springs, one near each wheel. For A part 1 we need to define the moment of a force about a point. Well, the moment of a force about a point is equal to the force multiplied by the perpendicular distance between that point and the line of action of the force. In part 2 we need to state and explain which pair of springs, the front or the rear springs, will be compressed the most in the truck. Well, for this I've done a simplified version of the diagram. We have the weight acting down here at 14,000 newtons. This is 1.4 metres from the front wheels. The distance from the front to the back wheels is 2.5 metres, meaning we can add this distance as being 1.1 metres. The rear spring, the one here at A, is closer to the centre of mass, and so this will be compressed more than the front spring. In part 3 we're asked to take moments about axle B to calculate the force exerted on the truck by each of the rear springs. Well, moments about point B, acting anti-clockwise, we have 14,000 newtons multiplied by 1.4 metres, and this equals the force due to spring A multiplied by 2.5 metres, as I've written here. Rearranging for force A, we get this expression, giving 7,840 newtons. But this is shared between 2 rear springs, so each spring exerts half this force at 3,920 newtons. In B, we're given the spring constant for these springs at 100,000 newtons per metre, and we need to find the distance each will be compressed. Well, the spring constant equation is the force is equal to the spring constant multiplied by the change in length. So we can rearrange as the change in length is equal to the force over the spring constant. The force we've just found at 3,920 newtons over 100,000 newtons per metre gives a change in length of 0.039 metres. We could write this as 39 millimetres. In C, we're told the springs must not be compressed by more than an additional 0.065 metres, and we need to find the maximum load that could be placed at point X, directly above the centre of the rear axle. Well, for this we can use force is equal to spring constant times change in length, and this is 100,000 newtons per metre, the spring constant. The additional change in length of 0.065 metres gives a force of 6,500 newtons. This is the maximum load on each of 2 springs, so the maximum load at X is 2 times 6,500 newtons, giving 13,000 newtons.